Next, another one more unit in the CSIR point of view. Another one more is the chemical kinetics. Chemical kinetics, which is mentioned in the CSIR as well as GATE examination point of view, like that, chemical kinetics. So in the chemical kinetics point of view, so we have seen some of the basics. What is an order, molecularity? So before going to topic, right? So first order is what, second order is what, third order, because first order, second order, third order also sometimes questions are there based on that, right? So after that, complex reactions are there, and collision theories, and enzyme catalysis, right? Like that it may be going on. So now here it is chemical kinetics point of view. Generally the chemical kinetics point of view, you have to measure the rate of reaction. So the rate of reaction, how this is rate of reaction is proceeding under the given conditions of the concentrations, temperatures, pressure. Under these given conditions, how the rate of reaction is proceeds. So this will be explained by the chemical kinetics. Chemical kinetics is explained like that. And chemical kinetics also explains some of the most of the reactions. Mechanisms also can be explained by the chemical kinetics by using that, right? Rates of reactions will be considered, right? So now here in this case, the chemical kinetics point of view, what is rate of reaction? How can you express the rate of reaction? Rate of reaction, how can you express this? The rate of reaction, how can you express in that? Or rate law equation, but how can you express that? So suppose if it is general reaction, if it is suppose A to P, A2 products formation takes place, A is a reactant molecule, A is a reactant molecule, and product formation takes place is P, reactant and products will be there, suppose. In this reaction, suppose, in the chemical kinetics point of view, while reaction is going on at any time, under any time, well, reaction is proceeds anytime, the concentration of the reactant molecule, concentration of the reactant molecule or species or ion, whatever it will be, the reactant molecule, so is decreases at the same time. Concentration of the reactant molecule decreases at that given time, at that time t. Concentration of reactant molecule is decreases while reaction is proceeds, and similarly during this reaction the concentration of product here it is increases at that time t. Concentration of the reactant is decreases and concentration of the product is increases while reaction going on, right? So according to that, the rate of reaction can be explained. Rate of reaction or is equal, while reaction is proceeds, the concentration of the reactant molecule is decreases with the time. So suppose if A is the concentration, A is the reactant molecule, its concentration suppose will be taken as Ca. Ca is the concentration of the reactant molecule A, or sometimes will be expressed A concentration. This is concentration of the reactant molecule A, or concentration of A is Ca, like this, right? So here it is, the reactant molecule concentration is decreases, with the given time dt. So that means d of Ca means this concentration of the reactant molecule A decreases is infinitely small, and infinitely small time which is taken dt. In a small time of infinitely small range of time it may be taken, and the concentration change it may be considered. So while in the case of the reactant, concentration is decreases. What is that? Meaning is minus is decreases the reactant molecule concentration of A in the given time. So that is equal to the, suppose in this case the rate constant is suppose K, rate constant or velocity constant is K. So that is depends upon, according to the law of the mass action, that is depends upon the K into, is depends upon the reactant molecule concentration. Is depends upon the reactant molecule concentration Ca. K into Ca or K into concentration of A. Reactant molecule concentration of A. And similarly, according to the rate law equation or rate of the reaction, in the case of, while in case of the considering the product also, while in the case not only for the reactant molecule, in this case also product also you have to consider. While reaction is proceeds, the concentration of the product molecule is increases or product species increases in the given time t. So the rate of reaction with respect to the product, rate of reaction with respect to the product. With respect to the product, what will happen? We have to increasing this concentration of the product molecule while time is going on. Reaction will be begins at time also. This is decreases, this is increases. Naturally, it may happen. So plus will be shown like that, increasing the product molecule concentration. Product molecule concentration is increases. So D of this product molecule concentration, suppose Cp, D of Cp by dt. D of Cp by dt, that is equal K into product molecule concentration. Suppose Cp is the product molecule concentration, or dP. So this concentration of the product molecule is expressed like this, dP by dt is equal K into concentration of the product molecule like this. That means while time is going on, the rate of reaction and time, rate of reaction and time t in a given time. So here in this case, the concentration of the reactant molecule is decreases. Concentration of the reactant molecule is decreases, and concentration of the product molecule is increases. Concentration of the product is increases. Concentration of the product is, all time going on, concentration of the product is increases and concentration of the reactant is increases. Based on that, rate of reaction will be there. Rate of reaction will be happen. Right? So the rate of reaction may be expressed in terms of the product or in terms of the reactant molecule. So, but whatever that here in this case, sorry, this is K into A. It may be depends upon the concentration of the reactant molecules only. According to the law of the rate equation, law of the mass action. So it always depends upon the concentration of the reactant molecule, K into A or K into A. dV by dt is also K into A, and this is also K into A or Ca is equal to similar one, it may be there. K into A or K into A here in this case. Right? So this is happening here in this case, generalized form of the rate of reaction. So suppose if the reaction will be given A plus B is glycerized to C plus D, A plus B is glycerized to C plus D. The rate of reaction or rate law equation, rate of reaction is equal rate of reaction is equal. How to express that? The concentration reactant molecules are A and B, product molecules are C and D. Suppose if rate constant or velocity constant is K, rate constant or velocity constant, sometimes rate of the reaction or velocity of the reaction, rate or velocity we use, rate constant, velocity constant, rate of reaction, velocity of the reaction, we are further using, anywhere we are using further point of view, right? So in the enzyme catalysis point of view, we are using rate of reaction and velocities of the reaction also, it may be mentioned, no problem. So A plus B is there. So concentration of the A decreases with a given time, dA by dt, or minus D into Ca, concentration of A, Ca by dt also. We have to use Ca or A, whatever it may be the concentration like this. And that is equal, suppose when it is taken, the reaction A plus B is glycerized to C plus D. A plus B is glycerized to C plus D. Rate constant is K. So this is the reactant molecules and this is the product molecules, right? So according to the law of the mass action, the rate of reaction generally, which is depends upon the concentration of the reactant molecules. Concentration of the reactant molecules. When rate of reaction is equal to one rate constant or velocity constant we have to use. So that means the concentration of the reactant molecules according to the law of mass action. So this is the rate of reaction. Rate of reaction. Now if it is given like this reaction, the rate of reaction during the course of the reaction, the rate while determining the rate. So while determination of the rate, while determining the rate, the concentration of the reactant molecules is decreases and product molecules are increases during the time with the time t, in a given time t. So that's what we have seen in the earlier one. The concentration of the reactant molecule A is decreases. That's what we have to use minus. And concentration of the reactant molecule B is decreases. We have to use minus dB by dt. And another one, the concentration of the reactant molecule, product molecule C is increases. We have to use plus dC by dt. So the concentration of the product molecule C. And another one molecule is D. Suppose we have to use plus d of d by dt. Right, AB plus CD or L plus M, whatever it may be, you have to use. So this is the reactant molecules case, this is the product molecule case. And this total one, this is the rate of reactions, which is equal to the which one? It depends upon the concentration of the reactant molecules according to the law of mass action. Then K into is directly proportional to that. Product, if it is proportional to this concentration, K is used, one constant. That K is a constant, is considered as the rate constant or velocity constant. This K is called as which one? Rate constant or velocity constant, or rate of reaction or velocity of the reaction. So this is rate constant or velocity of the constant. So if the concentration of the reactant molecule, suppose this concentration of the reactant molecule, suppose unity, this concentration which is taken as unity 1, then rate of reaction is nothing but the rate constant. Concentration of the reactant molecule is 1, the rate of reaction is rate constant or velocity constant. Now here in this reactant molecule case decreases and product molecule case increases according to the law of mass action, which is depends upon the reactant molecules concentration A and B. A is the reactant molecule concentration and B is another one concentration of the reactant molecule. Suppose in generalizer case, you have to use small a equivalents of A and small b equivalents of B, or plus small c equivalents of C, whatever it may be you can use. Here it is reactant molecules, two reactant molecules, small equivalents of A and small b equivalents of B, and small c equivalents of C and small d equivalent of D is the product molecule. Rate of reaction is maybe takes place. Reactant molecules convert to the product. So the rate constant or velocity constant is K. In generalize this equation, in general purpose. In general, this equation will be considered. The rate of reaction R is equal, rate of reaction R is equal, rate R is equal. So the reactant molecules case decreases. Now here in this earlier one is also decreases, but one equivalent will be mentioned, not mentioned particular number of equivalents. But here it is A equivalents of A, small b equivalents of B is mentioned. So you have to use minus is for the decrease in the reactant molecules concentration. So that's what minus we have to use. And A equivalents are there, we have to use 1 by A, dA by dt. In generalized purpose, any equation is given, N2 plus 3H2 is greater than to 2NH3, or any equation is given. Further number of applications are there based on these problems also there. Examinations point of view also sometimes problems also given. So sometimes so this type of reactions will be given. So dA by this one is equal to one concentration, one rate constant is given, K1 or 2 K1 something it may be given, and another one it is given, K2 or K3 is given, another one which is given. The relation between K1, K2, K3 like that, the problems are there. Next I can explain how to ask the question, examinations point of view questions. So this is the rate of reaction, while in the case of the reactant molecule minus 1 by A into dA by dt. In the case of B, minus B into dB by dt. And in the case of product molecules, plus 1 by C into dC by dt. And in the case of the product molecule D plus 1 by D into small d into d of d by dt is equal, which is depends upon the which one? Concentration of the reactant molecules. Then K into concentration of the reactant molecule is A and B, A equivalents of A and B equivalents of B. So this is in generalized purpose. Generalized reaction will be given. Right? Anyone if it is given, you have to apply this. Next, another one important one concept before going to the topics, order of the reaction. Order of the reaction, some basic point. This is also, you know that very well. Order of reaction is what? So the order, how can you determine like this? The number of atoms or molecules or ions or reactant species. Number of atoms or molecules or reactant species or ions or reactant species. Number of atoms or molecules or ions. That ions or molecules or atoms are reactant species, right? So whose concentration is changed? Whose concentration is changed or alters? Whose concentration is changed or alters during the rate determination process. During the rate determination process. During the rate determination process. The number of atoms or molecules or ions whose concentration is changed. These atoms or molecules or ions are reactant species. Atoms, molecules or ions of the reactant species. Ions of reactant species. Reactant species whose concentration is alters during the rate determination process. So during the rate determines process, how can you determine the rate? During the course of the reaction. During the course of the reaction, the molecules or atoms or ions concentration is changed. That number is called as the order. That number is called as the order. Or in other words, order is called the sum of the powers of the which one? Concentration or pressure. Sum of the powers of the concentration or pressure terms. Concentration or pressure terms of reactant species. Pressure terms of reactant species. Reactant species is called as the, or reactant molecules is called as which one? Order. Is called as the order. The sum of the powers of the concentration or pressure terms of the reactant species whose concentration is changed generally. This depends upon the order, depends upon the concentration is changed during the reaction process. The molecule or ions or atoms concentration is changed. The rate which will depends upon only that molecules. The order which is depends upon only that molecules. Right? So that is considered as the order. Sum of the powers of the concentration terms of the reactant species. Suppose if it is given like this generalized reaction will be given in the earlier one. A equivalents of A, B equivalents of B is going to be products formation takes place P. Products formation takes place. The rate of reaction which is depends upon the concentration of the A and concentration of the B of B. So the order of reaction will be considered. Order of the reaction, the powers of sum of the powers of the concentration or pressure terms of the reactant species. A and B is the reactant species. The powers which is considered as small a plus b. A plus b is the order of the reaction for this if it is given like this. Right? And order of the reaction, it is order can be determined in experiment point of view only. Order can be determined in experiments. Further, molecularity is also there. The molecularity will be depends upon theoretical also, but order can be determined experimentally only. So based on that order it may be as a whole number. That means as an integer values is possible, or it may be the fractional values also possible. Order values may be integer or fractional, 1 by 2, 5 by 2, 3 by 2, like that. Fractional values also possible, and zeros also possible. Or it may be integer, fractional, or it may be zeros, or sometimes it may be negative is also possible. Sometimes negative is also possible. Negative values also it may be possible. But the molecularity, what is a molecularity? I can explain here in this case only. Not much more time I can take. Molecularity. The molecularity can be determined in the single step. That step it may be the rate determining step. In the rate determining step, that is the slow step. That is the slow step. In the rate determining step, how many number of it may be number of steps are there, only we can depends upon rate determining step. So in that rate determining step, the number of atoms or ions or molecules will be participated. That one is considered as that molecules powers are considered as the molecularity. That one is considered as the molecularity. The number of molecules or atoms or ions which are participated in the rate determining step, that number is called as the molecularity. That number is molecularity. So that ion concentration is changed or not, no need to, is not depends upon like that. So here in this case, the concentration of the atoms or molecules or ions, it may be altered or changed. But here it is, it may be changed or not, which is may be changed, may not. So that's what the molecularity, which is different compared to the order. And this molecularity values, it may be integer values only. No, not fractional values, right? So not negative values. So like this values, it may be always integer values. And these values, it may be theoretically, we can determine just number of atoms or molecules it is participated in the rate determining step. Whose concentration is changed or not, during that means that will be affected the rate of reaction, it is not matter. So how many of the number of molecules are participated, just it is there, that is the molecularity. Number of molecules are participated in the rate determining step. So if it is further point of view based on this molecularity and order, so the reactions, it may be first order and second order and third order reactions also there. First order, second order, third order is also there. So based on the concentration of the powers of the reactant molecules. First order, second order and third order is also possible. So when order and molecularity, if it is different, suppose molecularity and order is different, that reactions are called as the pseudo order reactions. When molecularity and order is different, that reactions are called as the pseudo order reactions. That one is called as the pseudo order reactions. Suppose when it is molecularity and I mentioned that molecularity and order, if it is different, order is different, that reactions which is considered as which one? Pseudo reactions, pseudo order reactions, pseudo order reactions. Suppose for the hydrolysis of methyl acetate, in the presence of acid catalyst, like that. So hydrolysis of methyl acetate in presence of catalyst. So CH3COOH plus CH3OH. Right, so this reaction, for this reaction, order it may be 1, that means this order it may be the rate of reaction which is depends upon methyl acetate molecule only, not depends upon the concentration of the water. Water is taken in excess, that the concentration is not alters the rate of the reaction. So that means during the rate of the reaction is directly proportional to the methyl acetate only. Methyl acetate concentration. How many reactant molecules? Only one reactant molecule, one equivalent of methyl acetate is there, so that order is 1. But molecularity point of view, molecularity is 2. How many number of molecules are participating? Whether it is the concentration is changed or concentration is alters the rate of reaction or not, it is not a matter. So how many number of molecules are participated? 2 molecules are participated. Based on that, the molecularity is 2. So molecularity is 2 and order is 1. That it may be different. This is considered as pseudo reaction. This reaction is considered as the pseudo first order reaction. Pseudo first order reaction. Pseudo first order reaction. Now, based on the reactant molecules concentration, whose concentration is changed during the rate of the reaction or rate determinant process. So, depending upon that reactant molecules, the order of the reactions, it may be first order, it may be first order, or zeroth order is also there. In zero order is also there. In zero order means when it is zero order is 0. In zero order reactions, order is 0. Order is 0 means the rate of reaction is independent on concentration of the reactant molecule. Is not depends upon the concentration of the reactant. So rate of reaction is not dependent on which one? Concentration of a reactant molecule. Concentration of the reactant is not depends upon independent. So is not depends upon independent. So that's what that reaction rate of reaction is not depends upon the concentration of the reactant molecule. There is no concentration of the reactant molecule. So that power it may be 0. That it may be considered as zero order. If order is 1, order is equal to 1, that reactions which is called as the first order reactions. Order is 1, that is called as the first order reactions. In first order reactions, the rate of reaction or velocity of the reaction, K into, so if the reactant molecule, suppose A is the reactant molecule, their power it may be 1. So that order is it may be the first order. Here in this case, which one? The rate of reaction is equal to K into A is the reactant molecule is 0. That means it not depends upon the reactant molecule concentration. It indicates as K into A to the power of 0. That is 0 order. This is A to the power of 1 first order. A to the power of 1 first order. And order is equal to, suppose order is equal to that reactions which is considered as which one? Second order reactions. This order is equal to 1, that is first order reaction. Order is 2, second order reactions. In the second order reaction, suppose the rate of reaction which is depends upon which one? 2 reactant molecules concentration. If it is only one type of reactant molecules are there, A is the reactant molecules, 2 equivalents are there, A square. So this is the order is second order, or it may be expressed another one more, K into A into B. That powers of the 2 reactant molecules, 2 different reactant molecules is given, A plus B. And here in this case, same reactant molecule with 2 equivalents. So here in this case, order is 1 and this is also power 1. The sum of the powers which is considered as the order, 1 plus 1 is 2. This type it may be possible. And if it is order is, it may be 3. Order is 3, that one is considered as the third order reactions. In these reactions, the rate of reaction is depends upon rate constant, directly proportional to the concentration of the reactant molecules. When proportionality is removed, one constant, that is rate constant or velocity constant. So the rate of reaction or velocity of the reaction K into, so it depends upon if it is one type of reactant molecule is there, A to the power of 3. That means which one is the reaction? 3A is glazerized to product like this. So a to the power of 3 or k into a square and b. So b to the power of 1, that means a square into b means b to the power of 1. So this is 2 plus 1, 3. This is third order reaction. That means which one? 2 equivalents of a plus 1 equivalent of b. Or this one can be expressed like this, k into a to the power of 1 and b to the power of 2. B to the power of 2, that means 1 plus 2. That means a plus 2b is glycerized to the products. Or k into, in third order reaction, a, concentration of a, concentration of b, concentration of c. All reactant molecules, it may be different, a plus b plus c, a to the power of 1, b to the power of 1, c to the power of 1, a plus b plus c is glycerized to the product. So this type, all these reactions, the order, all this one, it may be the rate of reaction, it may depends upon the 3 species, so that it may be order is 3. Right? So suppose order is equal to n, this is considered as nth order reaction. Order is n, that is considered as the nth order reaction. In nth order reactions, the rate of reaction, that is equal k into, suppose A is the reactant molecule, over n is there, that n is the order, nth order reaction. Right? So based on that, we go for the first one in the 0 order reactions. 0 order reactions, first order, second order and third order and nth order also. Nth order means generalized principle can be obtained for all these first order, second order and 0th order case. Right? So based on this also questions are there. Right? So for this purpose, even though you don't have any idea about the kinetics, no problem. Right? So you follow my classes. Right? Then you are rich in the kinetics subject at last. See, listen. The 0 order reactions. 0 order reactions. First one, 0 order reactions. So the 0 order reactions case, what will be happen? The rate of reaction is not depends upon the concentration of the reactant molecules. Rate of reaction not depends upon. That means independent. Rate of reaction, already I mentioned that, not depends on concentration of reactant species. Concentration of reactants. Suppose the reaction, it may be given A to P, P is the products, A to P it may be there. So at time, initial time T is equal 0, initial time T is equal 0, the concentration of the reactant molecule, suppose A, and this product is not there at the beginning, product is not happened, cannot generated. After some time, some course of the reaction after some time, so the product it may be X, suppose how much the reactant molecule is left, A minus X, the product formation is X, how much the reactant is left before A, and this is X, A minus X is the left of the reactant molecule. How much reactant molecule is left, A minus X, how much product formation, X, during at the time of T. So the rate of reaction here in this case, suppose K naught, if it is 0 order, we may consider K naught, right? So based on this, the rate of reaction is depends upon or is directly proportional to the, generally which one? Concentration of the reactant molecule. So here it is reactant molecule is A, but according to the 0 order, the rate of reaction is not depends upon the concentration of the reactant molecule. So that's what we are using, A to the power of 0. Something to the power of 0, that value is 1. That means independent. So when proportionality is removed, we have to use K into A naught. K into A naught. Now this rate of reaction can be expressed, rate of reaction is expressed in the case of the reactants or in the case of the products, I mentioned that. So the reactant molecules concentration is changed the reactant molecule concentration is changed, that is decrease the reactant molecule. So minus dA by dt is equal k into a to the power of 0. This k is k naught, 0 order rate constant of the 0 order. So k naught is what? 0 order rate constant. 0 order rate constant. I mentioned that rate constant, when concentration of the reactant molecules are 1, then rate of reaction is nothing but the rate constant. I mentioned that. So k naught is the 0 order rate constant. So while expressed in the case of the reactant molecule, minus dA by dt is equal k naught into a to the power of 0. So based on this, when it is shifted to like this, minus d of a is equal k naught into a to the power of 0 into dt. This dt is shifted to the right side. And something to the power of 0, that value is 1. And both sides we can express we can take the integration, and limits will be taken. A to concentration of A is changed from A to A minus x, A to A minus x, that is equal k naught into, this value is 1, something to the power of 0, that value is 1, k naught into dt, while integration will be taken, and time will be changed from 0 to t, initial time is 0, so time 0 to t minutes, seconds, whatever it may be, can take 0 to t. So integration derivation is cancellation takes place. So what will happen? So concentration of A to A minus x is equal k naught into t and 0 to t. So one time you can substitute A minus x, and another one time you can substitute A minus x minus A is equal k naught into, here it is t minus 0, upper limit minus lower limit, upper limit one time and lower limit. So this minus a and plus a is cancellation takes place, and minus into minus is plus. So that's which one will be happen? X. Which one will happen? X. So x is equal k naught into t. X is equal k naught into t. Then k naught is equal to what? X by t. K naught is equal x by t. This is one type of rate constant, 0 order rate constant. K naught is equal x by t. Or the rate of reaction expressed in terms of the products case also we may be expressed, whatever it may be, we have to express it. dx by dt also is there in generalized purpose. We may express dx by dt. That is depends upon the k into concentration of the reactant molecule is 0. So a to the power of 0, that is 1 k. Here it is also, or this one purpose also, this one, or here in this case, k dx is equal k into dt. Both sides we have to take the integration, and integration derivation is cancellation takes place. This is k naught into t. Easy step also we have to use. Or sometimes it will be given instead of a and instead of a minus x, sometimes will be mentioned in some of the examinations. At time t is equal 0, this initial concentration is C naught, and this is 0. After some time t is equal some time t, so this is C, and this is C is mentioned here in this case. In the place of a minus x, C is mentioned. In the place of a minus x, C is mentioned. So here in this case, C naught and C is mentioned. Whatever that it may be, product formation takes place. After product formation takes place, the concentration is changed, that is C. This is A is equal, sometimes it may be mentioned here in these equations, from here in these equations, or here in this equation. Sometimes in this equation will be mentioned in the place of a minus x and a. In the place of a minus x, this concentration is C, and initial concentration is C naught. After some time, how much concentration of the reactant molecule is left, that is C, sometimes will be mentioned. So based on that initial concentration C naught, after some time C is mentioned. Based on that, sometimes it will be given. So what we have to use instead of the a minus x, so which one will be written? C minus C naught is equal k naught into t. This one is also. So based on this, minus C, minus into minus is plus. What we have to use? C naught minus C is equal k naught into t. then K naught is equal 1 by T into C naught minus C also. C naught minus C also. Sometimes it is also expressed like this. In some of the books it may be also mentioned. That's right. So now here in this case, X is equal K naught into T or K naught is equal X by T is there. So based on that, the units will be mentioned. X units are the concentration. So moles per liter, mole per liter or moles per liter, and this is time T is seconds or minutes, whatever it may be, we can take. So then what will happen? Mole by liter, that means mole liter inverse, and second is going to be, denominator is going to numerator second inverse. This is the units of the K naught. Units of the K naught is what? Mole liter inverse second inverse. Right? And sometimes the plot between, based on this, the plot between or dx by dt versus K naught, dx by dt versus time, sometimes the plots will be mentioned. Dx by dt versus time, depending upon the time. Here it is, when it is not depends upon the concentration of the reactant molecules, like here it is mentioned, or dx by dt, the concentration of the reactant molecule, concentration of the reactant molecules, like this, concentration of the reactant molecules, or concentration and dx by dt, this type of graph is there. So that means it not depends upon the concentration, that not alters the rate of reaction, not alters, it may be constant like this. It not depends upon the concentration of the reactant molecules. It is meaning is what? It is not changed, it is not depends upon the concentration, whether it is increasing or decreasing is not depends upon the concentration. Is maintained, depend upon the, with respect to the concentration, it is constant. So like this is also there. Sometimes the plots will be drawn in the zero order reactions. The zero order reactions. So here in this case, in this equation's point of view, minus of A minus X minus A is equal to minus K naught T is there. So here it is minus A minus X minus A is equal K naught into T. This minus is shifted to the right side. Suppose A minus X minus A is equal to what? Minus K naught into T. This is shifted to the right side from this equation. Right? And here in this case, A minus X is equal, this A is shifted to the right side. What will happen? Minus K naught T plus A is there. Minus K naught T plus A. If Y is equal mx plus c is there. Y is equal mx plus c. So in the y-axis, A minus x, and x-axis time t, and this is considered as the slope, negative slope. Slope is equal to minus k naught, and this is the intercept. Intercept is a. Intercept is a. This is one type of graph, it may be there. This is one type of graph which is there. And another one more type. Another one more. So you know that x is equal K naught into T or K naught is equal x by T. In the zero order reactions, K naught is equal x by T. K naught is equal x by T, you know that. Based on that, we have to calculate the half-life time, half-life, T half. T half we have to calculate, half-life, T half. So what is T half, half-life? So half-life means the concentration of the reactant molecule. So when it is x is equal to A by 2, half it maybe takes place. A is going to be A by 2. That means product formation is like that. X is equal to A by 2. In this reaction, K naught is equal to x by T. K naught is equal to x by T. If T is equal to T half, If t is equal to t of half time, it may be takes place. Suppose x is equal to a by 2, x is equal to a by 2 here in this equation, then k naught is equal, what is that equation? X by t, a by 2 by t half, a by 2 by t half. So based on that, t half if it is shifted to the right side, then a by 2 by k naught, that is equal, t half is equal a by 2 k naught, a by 2 k naught. So half-life in the zero order reactions, t half is equal a by 2 k naught, or k naught is equal a by 2 t half. So this is equal a by 2 t half. K naught is equal to a by 2 t half, or t half is equal 2 by a by 2 k naught. A is what? Initial concentration. So based on this, this t half is directly proportional to the a to the directly proportional to the a. T half is directly proportional to the a. Initial concentration, T half is directly proportional to the a. That is considered as zero order reaction. That is considered as zero order reactions. And a by 2 k naught. Based on this, a by 2 k naught, here it is there. T half is equal to a by 2 k naught. So suppose this is 1 by 2 k naught into a. This is equal to y is equal to mx type graph if it is there. Y is equal to mx type graph if it is there. In y-axis, what we have to use? Y is equal to mx type graph if it is there. In y-axis is t half, and x-axis is what? A. This is t half is directly proportional to is there. Yeah, when a is increases, t half is also increases like this. So slope which is equal to the what? 1 by 2 k naught. 1 by 2 k naught is the slope. So this type of reactions which is there, that is considered as the which one? Zero order kinetics. In zero order kinetics. Next one is the first order kinetics.